So I want to talk about the center of mass and its relationship to kinematics. So so far, all the objects we've been modeling as far as like projectile motion goes, like modeling accelerations on, that kind of thing, we've assumed to be kind of a spherical round object like this. Sometimes we have objects that, don't behave so simply. So imagine we have a baton, so some long, kind of rigid object like this, and let's say a baton twirler throws this thing up in the air and this thing starts twirling. So this thing's rotating. This part is going that way and this part is going this way. Well, obviously the motion of this thing is not so simple. If I try to model this part's motion, if I try to model the end of this, the motion of this, it's going up in the air, but it's also like twirling end over end. So the motion of this might be something like this, right? So it goes up and it's spinning. So the motion at this point might look something like that. Okay, one of the things we like to do in physics is simplify situations. So let's say I'm not concerned so much about this part of the baton, but I'm concerned about the baton as an entire kind of unit, right? The system that I'm considering is the entire baton. Well, I can model the entire baton. Its movement is really determined by its center of mass, which if the baton has a uniform mass throughout, the center of mass is simply in the middle. If the mass is concentrated, in different spots, like a hammer, for instance, has most of its mass like on this end, right? Over in this part with the hammer. The center of mass might be like somewhere here, because there is some mass over here, but most of the mass is towards the metal part of the hammer. So you can model the hammer's motion. If I throw a hammer up in the air and it's spinning, you can model its motion as a whole by tracking the center of mass. Okay, so the center of mass doesn't rotate. The object rotates around the center of mass, which makes things easy. So if I throw a baton up in the air or a hammer up in the air and I'm looking at its center of mass, its motion is it goes up and then it comes back down. And if I throw it at an angle, it goes up and then goes back down, right? I know that's not the best drawing, but you get what I'm saying here. So whenever you're trying to consider the object as a whole, its motion overall, use the center of mass and then simply work it just like you would any other kinematics problem. So some of the problems we might face in here are finding the object center of mass and then simply modeling the motion around the center of mass. Okay, and this applies to anything, like any super complicated structure. You could have, you could have a chandelier that has multiple components, and so the chandelier breaks off the chain and goes flying. Well, the overall motion of that thing is modeled by the center of mass, even though the behavior of the individual components may be more chaotic. So that's all I have to say on the center of mass for now. When it gets time, we'll calculate where the center of mass is later on in the course. But I'll see you in the next video. I think this concludes the one for kinematics, but we may have more in the future. All right. There we go.